Now, we'd said that the volcanoes that you get on Earth have a lot to do with plate tectonics. For example, you get subduction along in here as the Americas are heading west, overriding the ocean floor. The ocean floor gets subducted. Volcanoes just inland of there. So these are a lot of active volcanoes along there. A lot of active volcanoes along here, along plate boundary. A lot of active volcanoes along the plate boundary there. Active volcanoes there. We got rifting occurring in here. You got rifting in here. Rifting in here. More rifting around in there. So you get volcanoes, all those sort of places in there, and that kind of makes sense, sort of what's going on. It kind of explains what we're seeing right here, except for a couple of things. There's a few places where there are just these volcanoes out here, just right in the middle of stuff, and it's like, well, what are those volcanoes doing right there? Because that's not near a plate boundary right there. Okay. So again, putting it all together, we got these volcanoes, got the ring of fire, we got subduction, we've got subduction, we got rifting. Almost all of these volcanoes can be explained as being related to continental motion. Now, there's a couple places that doesn't apply to, in which you just have these volcanoes sitting out here, and they're not really at a plate boundary. So what's going on there? The most obvious and famous of these are the Hawaiian Islands. So the Hawaiian Islands right here actually turn out to be what we call a hotspot. If you look at the Hawaiian Islands, these are all volcanic islands. They were actually created by active volcanoes. And so, now the interesting thing is there are still active volcanoes here. We have Mauna Loa and we have Kilauea right here, active volcanoes. We've got Mauna Kea right there, which is considered an inactive volcano. It's not really extinct. It could erupt. It'd be very terrible if it did that because we got a lot of observatories on top of it. But it shows no indication of having erupted in a very, very, very long time, and no indication it's going to erupt for a very, very, very long time. Mauna Loa has erupted in the not too distant past, just decades ago, and Kilauea is the most active volcano on Earth. It erupts all the time. In fact, it just finished a long period of decades worth of erupting. The volcanoes on Maui are quite a bit older than the volcanoes on the Big Island. And you keep going, you get to Oahu over here, and those volcanoes at Oahu are even older than the others. And so you get, the farther you go, the older the volcanoes are. So what's going on here? It's believed to be that on Earth, deep in the mantle, that you've got a plume of stuff that's working its way up. And so it's working its way up, a plume from the deep mantle, and as it comes up, it's heating the ground underneath the crust. That makes this hotspot. The hotspot works its way up onto the surface. So what's happening is that you have the hotspot working its way up, you get a volcanic island. Well, plate tectonics moves that island over here, and then you get another island. And then plate tectonics moves those two islands over here, and then you get another island. So that means the farther you are from the hotspot, the older the island is going to be. And that's exactly what we see. In fact, turns out the hotspot is now just off of the Big Island, and there's a new undersea volcano that is forming a brand new island. Well, it's not going to be anytime soon, so don't plan on going buying real estate out here. But in the next, million years or so, there will be a brand new Hawaiian island out there. And I guess maybe not that long, next few thousands of years, there'll be a brand new island out there formed as as the plate is moving all of these things off of the hotspot. And so the volcanoes that are on the big island will eventually quit erupting, just like all the volcanoes on the other islands. Loihi is the name of this thing. It's called the Loihi Seamount. It's under the ocean floor, and so we call it a seamount because it's a mountain that's under the sea. How big are these things? Well, Mauna Kea, if you were to actually take it and put it, instead of standing on the ocean floor, it would stand up 10 kilometers high. That's actually higher than Mount Everest. And Mount Everest is really not even standing on the seafloor, it's standing on a plateau. So that means that it's not even standing at sea level, it's standing on a plateau. And so that means even though Mount Everest is vastly higher elevation, that Mauna Kea is actually a bigger mountain. What would happen if there's no plate tectonics? Well, it turns out Mars has no plate tectonics. And so if you have a hotspot on Mars, and there believes there was a hotspot on Mars, that would make one enormous volcano. And that is Olympus Mons. Olympus Mons actually stands 27 kilometers high. Here it is actually by comparison, drawn to scale with these other volcanoes right here. And so Olympus Mons, that's Latin for Mount Olympus. And that is this enormous, gigantic volcano that results from a hotspot on Mars, and there's no plate tectonics. Again, there's no plate tectonics on Venus, and there's evidence of possibly hotspot volcanism on Venus too. Again, vast mountains there, bigger than Earth mountains, but there's more gravity in Venus than on Mars, so the mountain doesn't get nearly as big as the Martian volcanoes do. Another thing that the Hawaiian Islands tell us is if you keep following the Hawaiian Islands out here, there's a whole line of undersea structures here. In fact, some of them come up to just below the surface of the waves, and coral deposits on top of them. You have atolls in there. You can actually have ships running aground in there out in the middle of the ocean, because they run into a mountain that comes right up to just barely below the surface of the ocean. Now, presumably, we know the ocean level rises and falls with climate change on Earth. So in the distant past, the ocean level was lower, and the distant past, the ocean level was higher. So it's possible that these were exposed at one point. Okay, keep going out here, and you actually come up with this mountain that comes right to the surface, and so coral, on top of it. So it's only a couple, feet, just a few feet above the surface of the ocean, and that's Midway. And so Midway Atoll, Midway Island, famous naval battle was fought around there. And that was actually part of this Hawaiian chain of things. You keep going further, and there's undersea mountains. But at some point out here, you notice that the line of undersea mountains changes direction. And so what does that mean? Well, what it means is that the ocean floor changed what direction it was drifting over that hotspot in the distant past. So this can help you figure out the sort of past motion that was occurring on the surface of the Earth.